Welcome to another video from the chapter Electrochemistry, and today I'll be talking about electrode potential, cell potential, EMF, electrochemical series, application of electrochemical series. In last video we talked about electrochemical cell, a device which converts the chemical energy from the spontaneous redox reaction into the electrical energy. Now in that case we have taken galvanic cell as an example, Daniel cell as an example, and that consists of two electrode, zinc electrode, copper electrode. When the two electrode is coupled through this conducting wire, then the bulb will start glowing, isn't it? Through this solid bridge the bulb will glow. Now why the bulb is glowing? As because the electricity is passing through them. Now why the electricity is flowing through them? As because there is flow of electron taking place. Now this flow of electron will take place only when there exists a potential difference between the electron. Now let us try to understand this cell potential, electrode potential. Whenever a metal is dipped into the solution, so there arise three possibilities. So in one case, so I'm taking example of zinc rod immersed in zinc sulfate solution. In first case, zinc ion collide with the metal, bounce back without any change. And in second case, zinc ion from the solution collide with this metal rod, gains electron from it and will get converted or reduced to zinc ion. Now in this case, this metal rod will acquire positive charge after losing electron. Now this will become positively charged with respect to the solution. So this is positive, this is negative. Now since there is charge separation, and whenever charge separations develop, so they develop a electric potential between the electrode and the electrolyte. So this is what called electrode potential. So now since here the reduction is taking place, so the electrode potential which is arising in this case is what we call reduction potential. And in third case, what happens is the metal rod loses electron and will go to the solution as metal ion. On doing this, the metal rod which have now electron will acquire negative charge. So in this case, a negative charge with respect to the solution. So here again the charge separation develop. Because of that, electrical potential will develop between this metal and this electrolyte. So this is what called electrode potential, oxidation electrode potential. So in simple word, so reduction potential is the tendency of an electron to gain electrode to gain electrons or to get reduced. And oxidation potential, it is every time the tendency of an electrode to lose electron or to get oxidized, and every time the value of the sign of these two have opposite sign. Let's say so zinc has the electrode potential as reduction potential as minus 0.76. that means its oxidation potential is positive 0.76 volt. So now we know that so all the electrode have different electrode potential. So now when the electrode having different electrode potential are coupled, then what happen? There will now take place the flow of electron from one to the another. Cell potential. Now, so according to present convention, the half cell reactions are always written as reduction half cell reactions, and their potentials are represented as reduction potentials. These are called electrode potential. Now let us take like this reaction is occurring at anode, and we know that in anode oxidation takes place. So now according to present convention, we need to write this in reduction form, that is Mn plus an electron, then Ms, then its electrode potential will considered as reduction potential, right? So this is a representation of reduction potential. Now when your concentration of the solution of the electrolyte is taken as 1 molar, and when the temperature is maintained at 298 Kelvin or 25 degrees centigrade and the pressure as 1 atmosphere, then that time the electrode potential will be your standard electrode potential, and this is designated as E naught Mn to M. So this is your electrode potential which is your reduction potential, right? And this is your standard electrode potential. Now EMF is the potential difference between the two electrodes. So we can write cell potential as E cathode minus E anode, difference of the two electrode, and standard one will be the E naught cell equal to E naught cathode minus E naught anode. Now EMF, again, it is potential difference when there is no current flowing through the cell. Now this is the maximum voltage that is obtainable from the cell, and this depends on the nature of the metal and its ion, concentration of ions in the solution, and the temperature. Now next, now it is not possible to measure the electrode potential, single electrode potential, as because in order to take a reaction to take place, the two electrodes should be coupled. So it's not possible to calculate single electrode potential or measure single electrode potential. So now in order to calculate the electrode potential, so we should know if we have the value of the one, then we could easily calculate the electrode potential of the other. So now the electrode potential whose value will be known to us is what called reference electrode. And in your syllabus, so your reference electrode which is taken into consideration is She, standard hydrogen electrode. Now the standard electrode potential of standard hydrogen electrode is taken as 0, and with respect to this or with reference to this we can calculate electrode potential, standard electrode potential of all the elements. Now see, now this consists of, okay, the platinum black, platinum coated with platinum black, and this is dipped in a hydrogen chloride solution of 1 molar, and continuously hydrogen gas is bubbled through it at 1 atmosphere. Now see here, all the conditions are in standard, so whatever standard value it have, so we consider that as standard electrode potential. Now in order to calculate the electrode potential of other electrodes, so this is coupled with the electrode. Now let us try to calculate the standard electrode potential of zinc with reference to She. So whenever the two are coupled, so it has been found that zinc electrode oxidation takes place and in She reduction takes place. So at anode, oxidation take, like zinc will get oxidized after losing 2 electrons to zinc ion, and cathode, at cathode this hydrogen ion will get reduced after gaining 2 electrons to hydrogen molecule. So the overall reaction taking place, reaction in the cell is, when you combine the two will get cancelled, zinc, same side zinc and your hydrogen ion, and the other side zinc ion and the hydrogen gas. Now representation of this cell. So whenever cell is represented, so how we write? Now the salt bridge is there, then this is your salt bridge. Left side will write anode. So anode, what is the change from zinc to zinc ion? This is 1 molar, right? And cathode will write on other side, right side, and what is the change out there? Your hydrogen ion, which is 1 atmosphere, is changing to hydrogen, 1 molar is changing to hydrogen gas, 1 atmosphere with platinum as a catalyst. So this is the representation of the cell, or this is the representation of your She when it acts like a cathode. Now the measured value of E naught cell is found to be 0.76 volt. E cell is equal to 0.76. Now what is E cell? It is E cathode, not cathode, minus E naught anode, and this is equal to 0.76 volt. Okay, now what is E naught cathode? So your hydrogen cell, right? So your hydrogen cell, every time we need to write this in reduction form whenever you are writing your electrode potential H plus to H2 minus, and anode your zinc, right? Again, you need to write this in your reduction form, okay, according to present convention, right? So 0.76 volt. Now this is your standard one. So the value of this we are considered as 0. So this is 0 minus E naught Zn plus 2 to Zn is equal to 0.76 volt. So therefore, what is your E naught? Zn plus 2 to Zn. So this is equal to minus 0.76 volt. So similarly, so we can calculate standard electrode potential of all the electrodes. So let's take one more example. Now let us try to calculate standard electrode potential of copper. To do that, we need to couple it with She. So when the two are coupled, in this case, the standard hydrogen electrode act as anode, and your copper electrode, it act as cathode. Now, what is the reaction taking place at anode and cathode? So at anode, oxidation takes place. So here your hydrogen will convert to hydrogen ion after losing 2 electrons, and at cathode reduction takes place of this copper ion to copper. Now overall reaction plus copper to hydrogen to copper solid, right? This is the overall reaction taking place. Now what is the representation of the cell? Again, salt bridge. So left side your anode, She. So anode, what is the change taking place? Hydrogen to hydrogen ion, 1 molar. Okay, this is 1 molar. Now platinum is there. Then cathode, copper. The change is from copper ion to copper. So this is the representation of cell. Now this is your electrode, your She when it act as cathode, representation of electrode when it act as cathode. Right? Now, so it has been observed that the E naught cell of this is this as 0. Measured value 0.34 volt. Now what is E naught cell? Again, this is your E naught cathode minus E naught anode. So which is equal to minus 0.34, right? Now what is E cathode? E cathode is your copper. So copper plus 2 to copper, and your anode is your hydrogen. Hydrogen H plus to H2. So this is minus 0.34, right? Now we know the value of this as 0. So what is E naught Cu plus 2 to Cu? Standard electrode potential of copper, it is, this is 0.34, okay? 0.34 volt. So this is how we can calculate standard electrode potential of all the electrode. So and when this standard electrode potential, depending on this value, when this electrode are arranged in a series, we'll get a series which is called electrochemical series. So electrochemical series, so it's an arrangement of various standard half cell electrode in order of their decreasing value of standard electrode potential or standard reduction potential. Now this is the electrochemical series where the electrodes are arranged in decreasing order of their standard electrode potential. So this is having like fluorine electrode is having the highest electrode potential, and the lithium is having the lowest electrode potential. Now let us discuss some of the application of this electrochemical series. So number one is relative strength of oxidizing and reducing agent. So we can identify with the known value of their electrode potential. Now with the one electrode with lower electrode potential. Now this type of electrode have the higher tendency to get oxidized. So that means, so they easily reduces the other elements, right? So that means they will act as a strong reducing agent. And the electrode with higher electrode potential, so they have higher tendency to get reduced, so that means they will act as a strong oxidizing agent. Again, the lower electrode potential, so any electrode which have the lower electrode potential will act as a strong reducing agent or the weak oxidizing agent. So and the electrode with higher electrode potential will act as a strong oxidizing agent. So just now we have calculated the standard electrode potential of zinc and copper electrode, right? So zinc ko kati aayo 0.76 volt and for copper it is 0.34. Now among the two, which will act as a strong oxidizing agent? So now let's go back to the same statement. The electrode with lower electrode potential will act as a strong reducing agent, and the one with higher electrode potential will act as a stronger oxidizing agent. So duijanama, so this is having the lower value, isn't it? Minus 0.76 and this is 0.74. So this is 34. So this is having lower value, so this will act as a stronger reducing agent. Again, so this electrochemical cell will help us to calculate EMF of the cell. So now what is EMF? So it is equal to E naught cathode minus E naught anode. Now how to identify when the two are coupled? So how to identify one as cathode and one as anode? So every time E naught cathode, the value of E naught cathode is greater than E naught anode. So again, so if we have two electrodes like zinc and copper, so among the two, which one will act as a anode and which one will act as a cathode? If you see, so the value of copper electrode is 0.34, which is greater than that of zinc electrode. So in this case, again, copper will act as cathode and zinc will act as anode. And this we have already done in galvanic cell, right? Now third, so from that series we can also predict whether your metal can liberate hydrogen from acid or not. So now only those metal can liberate hydrogen from acid, so which has negative value of reduction potential or which will have less electrode potential compared to that of hydrogen electrode. So now again we know the standard electrode potential of zinc is minus 0.76 volt and that of copper it is 0.36 and hydrogen, what is it? 0 value. Now among the two, okay, which metal can liberate hydrogen from acid? It is your zinc, because it have negative value, isn't it? So त्यसले गर्दाखेरि, so whenever you have this reaction, so zinc can displace hydrogen from the acid, but copper will not displace hydrogen from the acid. So this is all for today. Thank you.